Today you're going to be learning about 9.6 factoring special polynomials. One of the big things that they're going to talk about in this section is perfect square trinomials, and this is when you work with a perfect square trinomial, you need to be familiar with squares and square roots. So if you look at the example that's given here, 4 squared equals 16. When we think about that, 4 times 4 equals 16. If you have 5x squared, 5 times 5 is 25, so you're going to get 25x squared. When you look at this, 16 and 25x squared are examples of perfect squares. And when we look at this also, we think 4 and 5x are going to be called square roots of 16 and 25x squared. When you're looking at a polynomial, in this section we're going to be recognizing if a polynomial is a perfect square trinomial. And we look at this by thinking of 3 steps. I give you the first example here, which is x squared plus 16x plus 64. And so we're going to look at these 3 steps to determine if x squared plus 16x plus 64 is a perfect square trinomial. So the first step is to look at the first term, and we have x squared is my first term. And is x squared a perfect square? Well, let's think about it. Is 1 a square number? Yes. So x squared is a perfect square. Then we're going to look at the last term, which is 64. And we think, is 64 a perfect square? Yes, because the square root of 64 is 8, and 8 squared is 64. So yes, 64 is a perfect square. Then we're going to look at our middle term here, which is 16x. And when we look at the middle term, 16x is twice the product of the square root of the first and the last term. So I showed, for example, what that means. When we say twice the product of the square of the first and the last term, that means twice the product, so twice times the first term, which is 1x, times twice times the last term, which is 8. What is 2 times 1x? That is 2x. What is 2 times 8? That is going to be 16. Actually, let's take that back. When you multiply 2 times 1x times 8x, that's just going to give you 16x. Sorry, I was looking too much into that there. So yes, when we look at this polynomial here, x squared plus 16x plus 64, this is a perfect square. There's also some rules that you need to consider when factoring a perfect square trinomial. The first rule that you're going to see is when you have, for example, a squared plus 2ab plus b squared, when you look at your binomials here, it's going to be set up as a plus b in the first set of parentheses, a plus b in the second set of parentheses. So since you have 2 binomials that are set up the same, then it's going to be equal to a plus b squared. And notice that with this situation, you have 2 plus signs in that polynomial situation. Let's look at the next one. It's similar to the last, but notice we have a squared minus 2ab plus b squared. And so when we set this up, when we factor this out, it's going to be beginning parenthesis a minus b, end parenthesis, then another set of parentheses with a minus b, and Notice how the two binomials here are a minus b, so the final answer is a minus b squared. Let's look, we have some examples of factoring each expression here. We have 9s squared plus 24s plus 16. Let's look at our first and our last terms, okay? That's going to be the easiest way to look at this right now. And we need to think what times what gives me 9 and what times what is going to give me 16. Well, 3 times 3 is 9, and 4 times 4 is 16. And when you think about it, when you take twice the product of the first and the last, does that add up to be the middle value? It does. So when I factor out 9s squared plus 24s plus 16, we're going to get 3s plus 4 inside the parentheses squared. The next example, we have 36a squared minus 60a plus 25. Well, let's think about this. Is 36 a perfect square, my first term? I need to think of the steps here. Is my last term a perfect square? Yes. What is the perfect square of 36? That's going to be 6. What is the perfect square of 25? That is 5. If you take twice the product of the square roots of the first and the last term, does that give you 60? Yes, because 6 times 5 is 30, 30 times 2 is 60. So, when we look at this, when I factor it out, it's going to be 6a minus 5 squared. In section 9.6, there's another term that we see. It's called the difference of two squares. And when we think of the word difference, that means subtracting. Let's look at this. When you multiply a plus b and then a minus b, the product is going to be a squared minus b squared. And you can also look at this too by thinking of the FOIL method. When you do a times a, that's going to give me a squared. A times negative b is negative ab. B times a gives me a positive ab. And positive b times a negative b gives me a negative b. The negative ab and positive ab cancel each other out, so you're left with a squared minus b. So if you're still struggling with how we got the a squared minus b, you can think of the FOIL method when you see these two binomials set up the way they are to help you understand some of these rules better. Below there are some examples, and I want you to state whether each expression is a difference of two squares and then explain. Well, let's look at the first example here. We have 4a squared minus 25, and is this expression a difference of two squares? Well, yes it is, because 4a squared is the square of 2a, and 25 is the square of 5. Since 4 and 25 are both square numbers, then yes, this expression is a situation where it's a difference of two squares. When we look at the next example, we have 9x squared minus 15. This is not an expression because 15 is not a perfect square, because a number cannot be multiplied by itself to get the value 15. This is the last rule that we're going to see. It's called rule for factoring a difference of two squares. Here we have a squared minus b squared. And how we set this up is we have a plus b in the first set of parentheses, a minus b in the second set of parentheses. And I have an example here where I want you to factor the expression. Well, let's think of this. What is the square root of 25? That's going to be 5. What is the square root of 81? That's going to be 9. So when you think about it, we want to set this up thinking of the rule for factoring a difference of two squares. If we said 5 is the square of 25 and 81 is the square of 9, then it's going to be 5w plus 9 in the first set of parentheses, 5w minus 9 in the second set of parentheses. Make sure you get your homework done. It is due on Thursday. Remember, we have block days Wednesday and Thursday this week. Your homework that is due Thursday is page 455, numbers 5 through 33 odd. We will be checking this in class on Thursday.